Good morning, all of you. Good morning. Please confirm if you can hear me properly. Yes, all right. Good morning, guys. Good morning. So let's wait for your friends to join in. What are we going to discuss today? We are going to talk about epoxidation, right? Yes. So we are going to study epoxidation. Very, very important. Let's wait for your friends to join in. Let's wait for 1 minute. Yes. Good morning, guys. Good morning. Chalo. So basically there are plenty of different reagents which are used for the epoxidation. We are going to look at some of them, and we are also going to see how the epoxides are reacting selectively, right, in the acid and the basic medium. Right, so first thing first, guys, before moving onwards, let me inform you about few things. That is, yes, so what is upcoming on Unacademy? We are doing name, reaction, and reagent series, right? So this is a revision series that we are doing, okay? So in the next session, what we are going to do is, that is in the month of August, we are going to continue the same series of name, reaction, and reagents, right? And there we are also going to practice previous year questions on this. Okay. So a little bit of practice on name, reaction, and reagents in the next month, in the month of August. So that will be revision plus practice. All right. Those sessions will be revision plus practice. The timing is the same, Friday and Saturday. Okay. So this is what is going to be for the next month, August, revision and practice. And for all those students, guys, who want to join Unacademy Plus, there are two courses which are going on. And these are not the only two courses. There are plenty of courses, right? But in my profile, you will see these two important courses, Impulse Detailed Batch and Chemithon Practice Batch. All right. So as the name goes, this is a detailed batch for all the topics of organic, inorganic, and physical. And this is the practice batch for all the important topics of organic, inorganic, and physical, right? So yes, and guys, there is a very good news about the CSIR UGC Net on Unacademy. What is that? That notes are going to be provided really, really soon. And there are two types of notes. The in-app notes, matlab ki you will be able to access the notes in your app only, and that is going to be available for the plus learners, right? And physical notes which are delivered to your home, that is going to be applicable for iconic learners, okay? And the in-app notes will be available in the app only, and iconic students will be available to access both of these physical notes as well as the in-app notes, right? So the notes are finally available on the CSIR UGC Net category on Unacademy. This is a very, very important news. So if you want to join Unacademy Plus or Iconic, this is the best time, guys, because the offer Unlock 20 has been changed, and yes, it is better now. You have plenty of discounts. Basically, 6 month subscription, if you are buying, you are going to get 1 month extra, and along with that you are getting 20% discount. 12-month subscription you're buying, you get 3 months free and 20% discount along with this. And 24-month subscription, you are getting 6 months free and 20% discount on the same by using the code. You have to use a referral code, which is Jagriti S Live. Okay. So this offer is only available till 29th of July midnight. So be careful about this. And today is the last day. So before midnight, you can join up. And what is the actual price that you have to pay for Plus or Iconic? These are the current prices or the usual prices. What you have to pay is, you are going to pay, let's say for 12 months, you are getting 3 months extra and 20% discount. You're paying only this much for Plus. And for 12 months and 3 months extra over here for Iconic, which will have the notes also, you're paying only 24,000, right? So this is a very very good offer, guys. You don't usually get these kind of offers on an academy, so ये बहुत ही अच्छा offer है. Please join within this time frame. Okay, if you join later, there's no problem, but आपका loss हो जाएगा उससे, इसलिए अभी join कर लो. And for the free classes, what are we going to do? We are going to do Battle of Poles. That is, on spectroscopy, we are doing Battle of Poles complete practice session. Yesterday we did UV visible spectroscopy. Today we will start IR, and the timing is 6:30 today. Timing थोड़ा सा change है, right? Because of a plus session, so it's 6:30. ठीक है? Yes, Purnima. All right. But जो लेना चाहते हैं उनके लिए ऑफर है, तो ले सकते हैं. And you can also join my Telegram group CSINet 2022, where you are going to get notifications about all the upcoming classes and the courses on an academy. Okay, so yes guys, let's start without any delay. Everyone has joined. आज हम बात करेंगे epoxidation के बारे में. Okay, all right. Okay, Purnima, that's great. Chalo, let's continue our discussion, guys. So basically, yes, what is the common reagent that we use for epoxidation? There are plenty of reagents. Yes, what comes to your mind when I'm talking about epoxidation? Yes, tell me. What comes to your mind when we are talking about epoxidation? Yes, metachloroperbenzoic acid, right? Yes, metachloroperbenzoic acid or tri, yes, trifluoro or simple acetic acid, per acetic acid. Yes, or in the presence of basic medium H2O2 and OH minus. This is a separate combination used for alpha beta unsaturated enone system. We will talk about that too. Then we have DMDO, isn't it? Yes, ये भी है हमारे पास में, DMDO भी है. Yes, any more? What else comes to your mind, guys? Epoxidation with TFDO, right? So we are going to look at all of these examples. We are going to look at all of the reagents one by one for epoxidation, and we'll see how they are being used for doing the epoxidation. Okay, let's start, guys. First of all, okay, so see, first we have to understand what is the mechanism of epoxidation. It is very much similar to the Baeyer-Villiger oxidation, that is, when you are using an electron rich alkene like this. Let's say it is tetra substituted alkene. तो दिस इज एन इलेक्ट्रॉन रिच alkene. ठीक है, सो मेटाक्लोरोपरबेंजोइक एसिड हो या फिर पर एसेटिक एसिड हो, which carbon, which oxygen is provided basically. So let's write per acetic acid for example. Yeah, it's a simple one, so let's write this first. Which oxygen is provided to the alkene? This one or this one or this one? Yes, so which oxygen is provided, guys? See, this oxygen has a delta plus delta positive charge on it. Why is that so? Because ये ऑक्सीजन जो है इसमें तो बहुत ज्यादा s कैरेक्टर है, राइट, बॉन्ड में. Why? Because it is having a double bond. What about this oxygen? This oxygen has to be electronegative. Why? Because it is close to the delta positive carbon over here. ये carbon delta positive है, so this oxygen has to be electron rich to stabilize the electrophilic carbon, right? And that is why if you write a resonance structure, you know, if you write a resonance structure in this way, you will find that okay, this oxygen is electron rich, तभी उसने resonance किया, but because of the huge minus I effect of this oxygen has to lose the electron density which shifts towards this oxygen over here. ठीक है, तो ये next to hydrogen जो है, ये वाला जो oxygen है, we call this electrophilic oxygen, isn't it? We call this electrophilic oxygen, right? तो ये oxygen जो है, this is going to be attacked by the alkene system. Let's see now. Okay, so see what's happening. Let's say you have CH3 or some other R group, doesn't matter. So this alkene is going to attack over this oxygen, the electrophilic oxygen. What happens next? Next is the bonds are going to move and the proton is also abstracted. Yes, good morning guys, good morning who are joining now. And you get epoxidation in this way. Plus, you are going to get CH3COOH. That is, after losing that excess oxygen, your peracetic acid becomes acetic acid, isn't it? So ये हो गया epoxidation का mechanism which oxygen is provided. The one which is connected to the proton, that is the electrophilic oxygen that we are talking about. Okay, that will be provided to the alkene. Now, guys, is it a concerted mechanism? Is it a concerted reaction, the epoxidation? Yes, absolutely it is concerted, which means that the oxygen is going to be delivered on the same side. Obviously, na three-membered ring है, trans कैसे बनेगा? नहीं बनेगा. Okay, until and unless you are taking a trans alkene. So, what do you think, guys? What is going to be the order of reactivity? What is going to be the order of reactivity of simple alkenes when I am having the डिफरेंट सब्स्टिट्यूशन ऑन दी एल्कीन. अगर मैं बोलूं कि एल्कीन पे मोनो सब्स्टिट्यूशन है, लेट्स से, yes, it is going to be less than this di substitution, cis or trans, whatever it is, right? And it is going to be less than tri and tetra substitution, absolutely. All right, less than tetra substituted, you know that. All right, very good. अच्छा, अब इससे less कौन होगा guys? Who is going to have a least order देन दिस द अनसब्स्टिट्यूटेड एल्कीन, मतलब कि इथीन मॉलिक्यूल. इससे भी कम कौन सा है रिएक्टिविटी में? अल्फा बीटा अनसैचुरेटेड कार्बोनिल्स, isn't it? Least reactivity. Yes, this is showing us least reactivity on the epoxidation by metachloroperbenzoic acid. ठीक है, तो हम ऐसे लिखना चाहिए order of reactivity. All right, we should write order of reactivity for metachloroperbenzoic acid या फिर any other per acid which transfers the electrophilic oxygen. Yes, यही होता है. क्यों ऐसा होता है guys? Because in this molecule this alkene is electron deficient. Yes, in this molecule the alkene is electron deficient. Why? Because the double bond is doing conjugation in the carbonyl, right? So this double bond, if it is attacking on the, let's say if this double bond is attacking on the oxygen, तो इस वाले कार्बन पे तो पॉजिटिव आ जाएगा ना, which is not favored. Let's say इसने एक ऑक्सीजन पे अटैक कर दिया, इस कार्बन पे पॉजिटिव आ गया, it is not favored at all, right? So that's why. Yes, yes, Divyanshu, why alpha beta unsaturated carbonyl? Yes, we are just comparing the order of reactivity कि electrophilic oxygen किस पे transfer हो रहा है, okay? And then we will also consider separately कि इसके लिए epoxidation करवाना. Let's say we want to do epoxidation on this system, then what are we going to use? Okay, just understanding the polarity of the bonds, right? So अब देखो, let's say you want to do epoxidation over here. Yes, guys, you want to do epoxidation, so electrophilic oxygen you cannot provide. What are you going to provide? You are going to provide nucleophilic oxygen. Yes, you are going to provide the nucleophilic oxygen like this. How can you provide nucleophilic oxygen? H2O2 or OH minus use करके. You are providing nucleophilic oxygen, okay, which can attack on this carbon, ये alkene. The bond is going to open up like this. All right, and when the bond falls back, the double bond attacks on this oxygen, ये निकल जाएगा यहाँ से. You get epoxidation. What do you get now? At first you had alpha beta unsaturated. You had alpha beta unsaturated carbonyl. What do you have now? Alpha beta epoxy carbonyl. Okay, right. अच्छा एक बात बताओ, is this mechanism concerted? ये mechanism concerted है just like the previous one? Is it one step mechanism? Is it? Absolutely not. This mechanism is not concerted. Not a concerted mechanism. Not a concerted mechanism like previous one. इसका consequence क्या है? इससे क्या हमें trans epoxide मिलेगा? नहीं guys, trans epoxide नहीं मिलेगा. Why? Because epoxides are three-membered ring, right? So it will favor to anyways form a cis junction only if there was a ring, right? But the mechanism is not concerted, that we have to know. ये enolate बना लेता है, enolate intermediate के through जा रहा है, right? Goes through the enolate like intermediate, so it is not a concerted mechanism. Okay, it is a, yes, two-way mechanism, right? Chalo, now we are going to see some examples of epoxidation. We have a lot to talk about, guys. We have regio and stereo, everything to talk about. Okay, chalo, let's discuss the examples. Okay, first thing, let's talk about regio selectivity. ये देखो, let's say I have this molecule and I have metachloroperbenzoic acid. Where is the epoxidation taking place? On which alkene? On the ring alkene or on the chain alkene? कहाँ हो रहा है epoxidation? Absolutely on the ring. Why? Because ring is di-substituted, no, more electron rich as compared to this. Yes, ये तो mono substituted है खाली. So definitely on the more electron rich side, the epoxide is going to form. This will be as it is, and that's going to happen जब हमने एक mole provide किया, only one mole provided. Okay, very well. So yes, now let's see another example which shows stereo. So look at this molecule, guys. देखो इसका difference बहुत ज़्यादा important है, that you understand. We have one example like this और एक और example consider करते हैं. Let's say this. Okay, so yes, where is the epoxidation going to take place? In option number 2. Yes मोहित, अभी इसी condition में, acidic condition के अंदर ही, like when you require a electrophilic oxygen. I'll tell you why. Yes, where is the epoxidation going to take place in this example? Yes everyone, how does the molecule look like? How does the molecule look like? ये कैसे दिखने में है? ये तो trans हो गया ना system. This is a methyl. It is providing you steric hindrance, right? You can roughly, actually alkene hai, you cannot exactly like write it like this, but you can roughly write it in this way. Okay, so this is a alkene which is a little bit away from the methyl. So because of the methyl interaction, yes, trans decalin type. So because of the methyl interaction, you understood कि इसका epoxide तो below ही बनना चाहिए, right? So you must get the epoxide below. Alright, so that is it. You are getting the epoxide below, correct? Below the plane, this is how the epoxide is going to form. Yes, makes sense. Okay. So for a double, see, it depends on the position of the double bond. अगर ये double bond यहाँ पे होता, let's say over here, तभी भी below का ही product मिलता. Okay, if the double bond was in between these two carbons, then also you will get the epoxidation below only. Alright, let me just erase this, otherwise it won't make sense. Now, looking at the third one, Where is the epoxidation going to take place? Above or below? Yes. So what do you say? See, if we want to write the system like this, let's say कि एक methyl तो above है, right? And the double bond is in such a way, right? जैसे कि ये carbon है guys. So this is supposed to be sp2 and sp2 is supposed to be like this. You are having a double bond over here, all right? And yes, what else could happen? See, you are having this methyl, this CH2 going below the plane. All right, this is going to go below the plane, and this carbon goes above. All right, all right, yes. So why have I written it like this? मैंने इसको ऐसे क्यों लिखा है? Or rather, I can write the molecule in this way also to understand it better. ये देखो, ये below the plane चला गया, right? Why have I written the molecule like this? To show you that when you are having a double bond on the junction like this, ये double bond का कोई fixed stereochemistry नहीं है that ये upper side है या below है. It is on the same plane basically. Same plane where this or the same line where this carbon is pointing. तो ये वाला carbon जो है, this is pointing below with respect to this one cyclohexene, right? So if it is pointing below, ये वाला carbon भी below जाएगा, right? Which means which face is less hindered, above face or below face? Which face is less hindered, guys? Yes, I've deliberately drawn the molecule in such a way so that you can see that the above face is less hindered. यहाँ पे जो epoxidation होगा वो below नहीं होगा, guys. It is going to take place above. Alright, so the epoxidation takes place above. Okay, makes sense? So whenever you are having something on this kind of a junction, you will remember that it is actually this kind of a molecule, right? The double bond is in such a way that above is the less hindered phase. So epoxidation or any other reaction will take place above. Okay, chalo. So we move onwards and we do more examples of epoxidation, let's say. Yes. So guys, वैसे तो epoxidation is very easy, and when you as you see the alkene, आपको alkene दिख जाता है, मेटाक्लोरोपर बेंजोइक एसिड दिख जाता है, तो आप क्या करोगे? epoxidation ही करते हो. CH2Cl2. Yes, you will do the epoxidation very well. Okay, because epoxidation में ये direct reaction है, right? Just insertion. It is it similar to the open book? Just to imagine. No, no, open book is different. ओपन बुक में दोनों कार्बन के ऊपर ना एक हाइड्रोजन होता है, या फिर लेट्स से एनी अदर एटम इज प्रेजेंट, सो दैट यू कैन इमेजिन कि अगर ये दोनों हाइड्रोजन्स ऐसे है तो दोनों रिंग्स ऐसे जा रही है, फॉर एग्जाम्पल, राइट? तो बोथ द रिंग्स आर लाइक दिस, कन्वेक्स इन कनकेव अप्रोच. बट यहाँ पे ऐसा नहीं है, यहाँ पे एक डबल बॉन्ड प्रेजेंट है. बट बिकॉज ऑफ दिस कार्बन द डबल बॉन्ड इज पॉइंटिंग डाउनवर्ड्स. ओके. Yes, what about hindrance by methyl? Yes, Vishnu, methyl is also there, but ये जो lower वाला phase है, this is more hindered. This phase is even more hindered as compared to this phase, right? चलो, so we move onwards to one very important conclusion, that is कि अगर हमारे पास कीटोन है और alkene है, दोनों है, if we are having both these things, then what is going to happen? Epoxidation will happen or Baeyer-Villiger oxidation will happen, because Baeyer-Villiger oxidation also uses metachloroperbenzoic acid. Yes or no? Yes, or both will happen. Let's see what's happening, guys. So in this molecule, when I am providing only a small amount of metachloroperbenzoic acid, the ketone and the alkene, they are far away from each other. Alkene is more electron rich. ठीक है, alkene is more electron rich over here, और more electron rich invite कर दिया इसको metachloroperbenzoic acid को. Why? Because it is transferring the electrophilic oxygen, right? It is transferring the electrophilic oxygen. Now let's look at one more molecule. Let's look at this. So what do you think? What is going to happen in this molecule after I'm providing metachloroperbenzoic acid? Yes, guys, what will happen in this molecule? Am I going to get epoxidation or Baeyer-Villiger oxidation? Absolutely. See, absolutely you are getting Baeyer-Villiger oxidation. Why? क्योंकि एक तो alkene इतना electron rich भी नहीं है. Also, it is sterically hindered. Below the plane is hindered and above the plane methoxy आ गया to cause hindrance, right? So it is a hindered alkene. We will write hindered alkene, and that is why Baeyer-Villiger oxidation takes place. Yes. Which carbon will migrate in the Baeyer-Villiger oxidation? This is a primary one. Alright, और ये देखो tertiary है, sorry, secondary and tertiary. Who is going to migrate? Absolutely tertiary, तो oxygen यहाँ लगा दो. Okay, this is what you have. Methoxy will be as it is, and the double bond is also as it is. Okay, yes, right? Some really important examples. Okay, let's consider more examples, guys. अच्छा, ये तो हुआ when you are using metachloroperbenzoic acid, simple molecules. Now who is asking me कि H2O2 और H plus कब use करते हैं? See, H2O2, let's say this is H2O2, alright, and if you are using H plus acid in this, what is going to happen? H2O2 क्या करेगा? It's going to take a proton, oxygen becomes positive. If this oxygen becomes positive, this oxygen becomes electrophilic in nature, isn't it? तो ये वाला जो OH है ये इलेक्ट्रोफिलिक बन गया ना, so that's why it is also going to provide you an electrophilic oxygen, not a nucleophilic oxygen. ठीक है? Yes, does not provide a nucleophilic oxygen. Nucleophilic oxygen कहाँ आएगा? In the presence of peroxide and base, any kind of hydroperoxide, not only just H2O2. अगर हम बोले tertiary butyl hydroperoxide, yes, what is its name? Tertiary butyl hydroperoxide in the presence of a base. ऐसे देते ना guys कई बार. It's not necessary you always get H2O2, right? This is also going to give you a nucleophilic epoxidation. So you basically just require a hydroperoxide, ROOH, hydroperoxide and a base. The R could be anything now. Alright? Yes, the R could be anything. अब ना एक बहुत important property है epoxidation की, that is directed epoxidation. Let's talk about this. Directed epoxidation. What is that? Yes, what is directed epoxidation? See, when you are having this molecule, a simple alkene, आपको पता है metachloroperbenzoic acid देने से क्या होगा? By providing metachloroperbenzoic acid, you are going to get the epoxidized product very well. But if you are adding an OH over here, is it going to change something? Yes. Is it going to make any difference? By providing OH on the allylic position, is it going to make any difference? Yes, क्या होगा? Hydrogen bonding होगी? Absolutely. Yes. So because of hydrogen bonding, yes, because of hydrogen bonding, you are going to get the major product, the epoxidation, the major product same side as the OH. ठीक है? और ऐसा नहीं है कि ट्रांस नहीं बनेगा. Obviously this is also going to form, but only in the minor concentration. See, 92 is to 8 का ratio है. 92 is to 8. How good is that? So that is because of the hydrogen bonding. Hydrogen bonding in between the existing OH and the oxygen of the metachloroperbenzoic acid, right? It is because of the hydrogen bonding that you are getting this percentage. ठीक है? Yes. Now, is it always going to take place? सारे polar group ऐसे ही देने वाले हैं या फिर सिर्फ OH? Let's check. If I'm having, let's say, acetate, OCOMe. If I'm having acetate and metachloroperbenzoic acid, same thing. CH2Cl2 ले लिया, 0 degree centigrade ले लिया, same thing, right? Yes. What is going to be the major product? Epoxidation on the same side or opposite side? Yes. Epoxidation on the same side or on the opposite side? No hydrogen bonding opposite. अच्छा देखो opposite भी बनता है same भी बनता है but what is the percentage? Let's see. Let's say this is OCOMe. You're having epoxidation on the same side. OCOMe. You're having on the opposite side. So for the oxygen, when you are having some acetate group or some methoxy group like this, उसके लिए दोनों बनेंगे guys and the percentage is like this or the ratio is like this 40 is to 60. ये ratio है इसका 40% 60%. Okay, so it is not that bad, right? इसका ratio इतना बुरा भी नहीं है. And for example, मैंने oxygen को हटा दिया. I'm just taking some other group. Let's say which group I'm talking about. Let's say I'm taking this kind of a molecule. SiMe2PH on the allylic position and then metachloroperbenzoic acid. Yes, तो अब क्या मिलेगा? Epoxidation on the same side or on the opposite side? So on the opposite side, I'm getting 61% and on the same side, I'm getting only 39%. Yes. Opposite side मिलेगा. See guys, why is this ratio? Why is it not 100%? ये तो steric hindrance cause कर रहा है ना. So the epoxidation must take place 100%. Why are we even getting this 39%? ऐसा भी क्यों हो रहा है? Yes, because epoxidation has two possibilities. From both sides it can take place. Just that the steric hindrance is going to affect the reaction a little bit and that is why 50% से ज़्यादा ये product बन रहा है. Okay, 50% से तो काफी ज़्यादा है 61%. So we can never say that अगर steric hindrance है तो ये 100% बन जाएगा. No, that we cannot say, right? So this is your major product absolutely, but not 100%. All right? Okay. Now, if I ask you that, are you ever going to get a trans epoxide? What will you say? कभी बन सकता है trans epoxide? Yes, if you are ever trying to make a trans epoxide, is it possible? Yes, why not? Alright, look at this molecule. Metachloroperbenzoic acid, CH2Cl2 and 0 degree centigrade. Right. तो अगर इस molecule में हमने epoxidation किया, are we going to get a trans epoxide? Yes, both of the terminal alkenes will remain unreacted क्योंकि we are only having 1 mole of metachloroperbenzoic acid. And yes, and what happens is more electron rich alkene will react. तो ये देखो, ये वाला bond है, this is let's say below the plane, this is your epoxide, and let's say this is above the plane, तो हो गया ना trans epoxide. The alkene was trans, so you are getting trans epoxide from the trans alkene. Yes, that is also possible, right? Getting a trans epoxide from a trans alkene is possible. अच्छा ठीक है, very good. Okay, now one more important information. देखो जैसे हमने directed की बात करी, directed epoxidation. So here we took the example of some group which is on the allylic position. Allylic position क्या होता है? This is your double bond. एक carbon छोड़ के जो एक carbon जो ये है sp3 carbon just next to this vinyl carbon is your allylic carbon. All right, fine. But if I say that I am having a OH group which is far away from this carbon. Let's say not on the allylic carbon. ये allylic carbon है but एक carbon छोड़ के है. It is not on the allylic carbon. Yes, is it going to influence? Is it going to influence the epoxidation? Let's say I'm taking the OH above the plane. Yes. अच्छा हाँ सॉरी इसमें एक ही है ये वाले पे टर्मिनल पे नहीं है so just eliminate this double bond. Yes, Mohit. Okay. Yes, we call this OH, the position, we call it homoallylic position. What is homoallylic? That is one carbon away from allylic. जैसे ये allylic है, so this is the one carbon next to it, this is homoallylic. Yes, is it going to influence? Absolutely, it will influence. Okay, very, very important. Even the homoallylic alcohols can influence this reaction. Alright. Yes. Now, let's see more examples. ये देखो बहुत अच्छा एग्जाम्पल है और बहुत अच्छा क्वेश्चन बन सकता है यहाँ से राइट लेट मी जस्ट राइट इट वंस so this is a direct example from Claydon solution manual I guess so look at this I am having two reactions you know this can be made into a question guys so be careful and just note this down very very important this is अगर मेरे पास ये molecule है for example alright. So even if the alkene is like not very electron rich, but phenyl group से electron rich है and sulfonyl group से electron deficient भी है, right? So Yeah, we can say that we can use both the reagents on this molecule. That is, we can use H2O2 and OH minus on this molecule, and we can also use metachloroperbenzoic acid. It's going to give us epoxidation in both the ways. Alright, now the question is, what is the stereochemistry of the product that you get? What is the stereochemistry of the product? मेटाक्लोरोपरबेंजोइक एसिड से क्या प्रोडक्ट मिलेगा और उससे क्या प्रोडक्ट मिलेगा H2O2 H- से. Very, very, very important example this is. Yes, guys, tell me. What is the stereochemistry? Are both of these giving cis epoxidation? H2O2 not concerted. Yes, H2O2 will give you trans. Absolutely. See, here you are going to get cis epoxide because metachloroperbenzoic acid is a concerted mechanism. Concerted mechanism, so it is, we call this stereospecific. Stereospecific epoxidizing agent हो गया metachloroperbenzoic acid, isn't it? Yes, but is it stereospecific too? Not at all. This is stereoselective. That it is going to give you a major and minor. Which means, which is the major product, guys? जब देखो possibility होती है rotation की, तो obviously the more stable one will form. Which is the more stable one? Trans. Trans is the more stable one. Yes, trans ज़्यादा stable होता है ना cis से. Absolutely. So trans is the major one over here. Okay, this gives you a cis epoxide and this gives you a trans epoxide. It is a very, very, very important example to be considered because we are comparing both of the reactions together. Okay, chalo. Let's consider few more examples, guys. Yes, let's consider few more examples. आज तो हमने बहुत ज़्यादा इपॉक्सीडेशन कंसिडर कर लिया. रिंग ओपनिंग कब कंसिडर करेंगे? नेक्स्ट क्लास में करेंगे. टुमारो वी हैव वन मोर सेशन. ओके, तो इपॉक्सीडेशन ही अच्छे से कर लेते हैं गाइस. तो इपॉक्सीडेशन के बाद जो रिएक्शंस है, दैट इज फ्रॉम द इपॉक्साइड फॉर्मिंग द डायोल्स, from the epoxide forming the azidine, right? From the epoxide forming different molecules that we are going to consider tomorrow कि अब epoxide further क्या react कर सकता है, right? चलो, yes. Now this is also a previous year question, guys. This has also been asked in a previous year question. Look at this. That is, obviously, if you are using metachloroperbenzoic acid, you get epoxidation. We have done plenty of examples of that. Lekin, if I'm using NBS and 20% NaOH, is there going to be a difference in the stereochemistry of the product? Very, very, very important. Once again, yes. Is there going to be a difference in the stereochemistry of products? You tell me. Yes. क्या बनेगा? What will form? Acha, metachloroperbenzoic acid will give you epoxidation on the less hindered side. Yes, because it's only a one step. ये देखो यहाँ पे क्या बनेगा? Metachloroperbenzoic acid gives you a one step epoxidation, right? So if the molecule is like this, that it's having a tertiary butyl group above the plane, okay, तो फिर क्या होगा? Epoxidation takes place below the plane. Absolutely. Yes, Vishnu, very good. Below and above respectively. What is happening in the next step? NBS क्या कर रहा है? NBS is providing this as a simple bromonium ion. What is that bromonium ion going to do? Bromonium ion भी इस पे attach होगा double bond के ऊपर. It is going to attack bromonium ion. अच्छा, from where does it attach? Attaches below the plane first of all, क्योंकि steric hindrance है ऊपर तो. So it gives you addition of bromonium ion like this. Very fine. Now what happens is OH minus is going to attack backside SN2 reaction. SN2 reaction. OH minus gives you, so this is an OH above the plane and there is a bromine below the plane. Absolutely. और फिर क्या होगा guys? One OH minus comes up and removes this proton which is going to attack on the carbon and bromine eliminates. तो ये देखो, it is going to give you the epoxidation above the plane. Even though there is steric hindrance, लेकिन क्योंकि ये reaction different method से हुआ है, involves various steps, it is giving you epoxidation above the plane. Very, very important. Okay, both of these are stereospecific reactions. They will give you below epoxidation and above epoxidation respectively. ठीक है, इसमें diol possible है. हाँ, why not? Diol is also possible, but since the OH minus can remove this proton from here, अगर आप diol बनाओगे ना मोहित, तो दोनों OH सेम साइड पे आने पड़ेंगे, which is not possible. Why? Because when already an oxygen is present, तो ये oxygen जो above present है, ये इसको NGP करेगा ना, NGP की पूरी possibility बन रही है, isn't it? So the OH minus is going to just remove the OH proton and there is a possibility for NGP, and that is why the epoxide forms, not the diol. Okay? Yes. Alright guys, we have done so many examples of epoxidation today. और एक देख लो, because stereo is always important. और एक देख लो, metachloroperbenzoic acid. Yes, what does it give you? Here, epoxidation is possible. कहाँ पे देगा epoxidation, above or below? Tell me quickly. Epoxidation above or below? Exo epoxidation. Very good. Epoxidation will be exo. Very good. About this one, yes, in this molecule, what do you have? Exo or endo? Alright, so because of steric interaction, yes, very good. Because of these two methyls which are present above the plane, what happens is, ये जो epoxidation process है, this cannot happen above the plane because it is hindered. So the epoxide forms below or endo. Hydrogen goes above. Alright. Yes, this is how the reaction takes place. Okay. और एक example देखते हैं guys. Let's say I have this molecule. I have cis junction. Both the hydrogens are on the same side, and I have metachloro perbenzoic acid. अभी कहाँ होगा epoxidation? Above or below? हाँ विष्णु है ना प्लस क्लास 10:30. You have 8 minutes. Yes, above, absolutely above. So how do you draw this molecule? You draw the molecule in this way. ये रहा आपका butterfly structure, if you want to call it. Low, right? So where is the epoxide going to form? Above the plane, absolutely. Above the plane is less hindered, right? So your product is actually going to look like this, above the plane. Okay? Yes, above the plane. Very good. All right. Another example of epoxidation, regioselectivity over here, metachloroperbenzoic acid. Where is the epoxidation taking place? Yes, yes, very good. On the middle alkene. That is over here. Alright, very good. This is the correct answer. So, yes, we have done plenty of examples guys today. और हमने काफी सारे एग्जाम्पल भी देख लिए, हमने मैकेनिज्म भी देख लिया है, रीजियो सिलेक्टिविटी एंड स्टीरियो सिलेक्टिविटी and the selectivity in reactions for the epoxide formation, right? Plenty of important examples are done today. So absolutely epoxidation is necessary, लेकिन epoxidation के अलावा epoxide बनने के बाद में क्या बन सकता है, that we will see in the next session, which is going to be tomorrow. So we have one more session tomorrow guys, right? The same timing. I'll just inform you in the Telegram group. Just be reminded about this कि कल एक session और है जहां हम ये complete करेंगे. Okay, and once again reminding all of you that the offer is valid till 29th July midnight. So if you are interested in joining Plus or Iconic, do so before this timing. जो ये आपका offer चल रहा है 12 months पे 3 months free है along with 20% off. 24 months पे 6 months free है along with 20% off, and 6 month पे 1 month free है along with 20% off. Okay, so yes, don't forget about this. Inform your friends if anybody is interested to join. You can use my code Jagriti S Live also. Chalo guys, I will see all of you now tomorrow. Bye everyone, take care of yourself.